This is the third video in the series about decimals, and if you were with me on the last video, you'll know that my hair was doing something weird right here. It was like sticking out, so I went to the bathroom, I wet it, and I dried it, and we'll see if this looks better. Doesn't look like I'd be somebody that worries about what my hair looks like, but every now and then, just gotta fix it. So, okay, for this video, we're finally going to talk about how to convert fractions to decimals, and these are going to be just any fractions, okay? It doesn't have to have a power of 10 for the denominator at all. Okay, so we'll do that first, and then in the last video we talked about comparing and ordering decimals. So what we'll do in this video, once we know how to convert all fractions to decimals, we'll also look at taking a fraction and compare it to a decimal, and then having a series of fractions and decimals that we can put in order. Okay, so let's get started. Okay, so converting fractions to decimals. All right, quite literally, all you have to do is divide the numerator by the denominator. Now, if you go back to the video that was number 1 in the series about decimals, we talked about 2 different types of decimals. You can have rational decimals, and those are the numbers that can be written as fractions, and all of those fractions have a decimal equivalent. So those would be the decimals that terminate or repeat. So in this video, you will see decimals that just terminate. Those always occur when you have a 0 remainder. You'll definitely see repeating decimals. You'll also see situations where the decimal terminates or repeats eventually, but it maybe doesn't happen for several decimal places. So what we do in those cases is we just round and we get an approximate. Okay, so let's go ahead and look at an example. So looking at 3/4, I would take 3, I would divide it by 4. Now, hopefully we all can agree that 3 will not go into, or 4 will not go into 3. Let me make that look better. Okay, but we also know that if we take a number 3, that is equal to 3.0, which is equal to 3.00, which is equal to 3.000000. You can add zeros to the end of a decimal. It does not change the value of the decimal. So what we'll do in this case is we'll add a decimal after the 3 and a 0. And then we can pretend this is a 30 instead of a 3, as long as we bring the decimal up into our answer. So that's our little shortcut. So now we're going to ask ourselves, does 4 go into 30? Yeah, sure does. It goes in 7 times. Now, 7 times 4 is 28. I subtract that, I get a 2. Now, I told you a minute ago, we're looking for decimals that either terminate or repeat. And to get a decimal that terminates, you need a 0 remainder. Well, we don't have a 0 remainder, so what we do is we add another 0 and we drop it down. Now, does 4 go into 20? Sure does. It goes in 5 times. 5 times 4 is 20. I subtract. There's my 0 remainder. So I can say that 3/4 is equal to 0.75. Okay, I'm going to get rid of all this junk right here so I have more room for problems. Okay, let's look at another one. So let's look at 2/5. Same thing. 2 divided by 5. 5 doesn't go into 2, but we can pretend the 2 is a 20 by adding a decimal and a 0. Just make sure you bring the decimal up into your answer. So now 5 does go into 20 4 times. 4 times 5 is 20. We subtract. We get a 0 remainder. 2/5 is equal to 0.4. And that's it. All right. What about 5/8? Okay, just a lather, rinse, repeat. Just keep this process going. 5 divided by 8. Well, 8 won't go into 5, but with a decimal and a 0, we can pretend 5 is 50 as long as we bring the decimal up into our answer. So 8 into 50 would go, well, 6 times. 6 times 8 is 48. I subtract and I get a 2. It's not a 0 remainder, so I add another 0, drop it down. 8 will go into 20 twice. 2 times 8 is 16. I subtract, I get a 4. Still not the 0 remainder I want, so I'm going to add one more 0, drop it down. 8 goes into 40 5 times. 5 times 8 is 40. there's your 0 remainder. So 5/8 is the same as 0.625. Straighten that up just a little. Okay, let's keep trying. We're just going to practice, do lots and lots of examples. Okay, 13/20. 13 divided by 20. Well, 20 will not go into 13, but it'll certainly go into 130. So let's see, 20 goes into 100 5 times. We could get another 20 out of 30. So that means 20 should go into 130 6 times. Well, 6 times 20 is 120. I subtract, I get a 10. That's not a 0 remainder, so I add a 0, drop it down. Now we do 20 into 100. 20 goes into 100 5 times. 5 times 20 is 100. There's our 0 remainder, so we get 0.65. Let's keep trying. So 13/50. Just like with all the previous examples, we take our numerator, 13, we divide by our denominator, 50. Well, shoot, I made that worse. 50 goes here. Now, 50 won't go into 13, but it will go into 130. So 50 should go into 132 times. 2 times 50 we know to be 100. We get 30 left over. Add a 0, drop it down. Now, 50 goes into 100 twice. So for each of the hundreds and 300, you'll get 2 50s. So 50 goes into 300 6 times. 6 times 50, 300. There's our 0 remainder. And let's do another example. Now, I like this example. In this example, we have 31/4. Well, you got an improper fraction, nothing changes. You could certainly convert this to a mixed number if you wanted to, but that would just be extra work because when we do the division, kind of works itself out. So we start with 31 divided by 4. So remember, it's always numerator divided by denominator. And in this case, 4 will go into 31. It will go in 7 times. 7 times 4 is 28. I subtract and I get 3. It's at this point that we would add the 0 and that decimal. Bring your decimal up into your answer, and then bring your 0 down into where you're dividing. Now, 4 into 30 will again go 7 times. 7 times 4 is still 28. I subtract, I get 2. I'm going to add another 0. 4 into 20 goes 5 times. 5 times 4 is 20. There you have your 0 remainder. So 31/4 is going to be 7. And then that leftover fraction part, if this were a mixed number, would convert to 0.75. So 7.75. So don't sweat it if you get an improper fraction. It's no big deal. Just divide like normal. What if we had a real mixed number this time? So instead of having an improper fraction, the problem was presented to you as a mixed number. No big deal. Still a piece of cake. We know this right here is the whole number. So we just bring it over, add a decimal, and then the stuff after the decimal is going to be this 3/8. So we want to figure out what 3/8 is. We take 3, we divide it by 8. 8, of course, doesn't go into 3, but that's not a big deal. We add a decimal and a 0. We pretend 3 is 30. So 8 would go into 30 3 times. 3 times 8 is 24. 30 minus 24 is 6. I add another 0. Let's see, 8 times 8 is 64, so 8's too many times, but 8 could go into 67 times. 7 times 8 is 56. Get a 4. Add another 0. 8 into 40 goes 5 times. 5 times 8 is 40. There's our 0 remainder. So 9 3/8 is the same as 9.375. Not bad. Dare I say fun? Let's do one more. So let's say I have 6 and 5/16. So we've got another mixed number. We know the 6 is just going to be the part before the decimal. And then 5/16 goes after the decimal. Now, 16 won't go into 5, but it will go into 50. In fact, 16 goes into 53 times. 3 times 16 is 48. Subtracting it a 2. Go ahead and add another 0. Now, 16 into 20 would just be 1. Add, oh, let's see, we subtract, we get 4. Add another 0. Well, 16 we know times 3 is 48. So 16 would only go into 40 twice. 2 times 16 is 32. I get an 8. Let's try one more division, see if that'll do it. Add another 0. It turns out 16 does go into 80 5 times. 5 times 16 is exactly 80. You get a 0 remainder. So 6 and 5/16 is 6.3125. Now, when you have a denominator like 16, a lot of us don't know the multiples of 16 really quickly or easily in our head. So I don't want you just using a calculator and cheating, okay? Because if you just rely on your calculator, in a couple of years, you're going to end up exactly where you are now, where you've lost a lot of those skills. You can't do some of the arithmetic or some of the steps by hand. You do yourself a disservice. But on a problem like this, where you maybe don't know all the multiples of 16, a couple of things you can do is just start listing out multiples of 16. Okay, just go ahead. If you see a problem like this where you've got 16 in the denominator, go ahead and write out maybe 10 multiples of 16. Another thing you can do is use a multiplication table in reverse to get your division. And then I'm not opposed to the calculator entirely, but still show the work of the long division on your paper. So like, for example, when we got down to this 80, and you're like, gosh, I don't know how many times 16 goes into 80. I'm okay with you doing 80 divided by 16, but you still need to do the work by hand, okay? Let's look at something like 2/3, okay? So same process as before. We take 2, we divide it by 3, and some of you might already know what's going to happen here because you might be familiar. 2/3 is a really common fraction. So 3 won't go into 2, but it will go into 20. It'll go in 6 times. Now 6 times 3 is 18, so we would subtract that, we get a 2. Well, when I add a 0 and drop it down, I get another 20. Well, 3 still goes into 20 6 times. 6 times 3 is still 18. I get another 2. So I could just keep this going. All right, this is a situation where you're going to get what we call a repeating decimal. So we can see that we're going to get 0.6 every single iteration here. So how do you write your answer? There is an exact way to write 0.6 repeating. Okay, you could round, but the directions don't specify rounding, so we want to say this equals. You take the smallest thing being repeated. The smallest thing being repeated is the 6. And so we write 0.6, and then we put a little bar over the 6 called an overbar. That tells me that this is really 0.6666666 repeating forever. So all of these examples here, those were considered terminating decimals. We got a 0 remainder, the decimal just ended. But for this example, we do get a situation where we're never going to get a 0 remainder. We're always going to get either one thing repeating or a pattern of things repeating, okay? Or a sequence of things repeating, we'll say. Let's look at another example. Let's look at 8/15ths, okay? So 8 divided by 15. Well, we already know that 15 won't go into 8, but it will certainly go into 80. So 80 divided by 15, let's see. I know that 5 times 15 is 75. So that's as close as I can get to 80 without going over. So I'm going to say 15 goes into 80 5 times. 5 times 15 is 75. I get 5 left over. Drop down a 0. Let's see here. Well, 15 times 3 is 45, so that's as close to 50 as I can get. So 15 into 50 is 3. 3 times 15 is 45. And there's that 5 again. Let's divide out one more time just to see what happens. Well, 15 into 50 is still 3. 3 times 15 is still 45, and there's that 5 remainder again. This tells me right here that I'm getting a repeating decimal. So my decimal is 0.53 and I want to put an overbar over just the 3. The only thing repeating is the 3, and we want to take the smallest amount of repetition and put the overbar over that. So the 5 does not repeat, just the 3. What if I had 3 11ths? Okay, so same old drill. 11 doesn't go into 3, but it will go into 30. So 11 times 2 is 22. That's as close as I'm going to get. So 2 times 11 is the 22. We subtract it, we get 8. Well, let's add a 0. The closest I can get with 11 going into 70 or into 80 would be 7. 7 times 11 is 77. I subtract and I have a 3 again. So let's see what happens here. Add a 0. Well, 11 into 30 is still 2. 2 times 11 is still 22. Well, there's that 8 again. So let's see. 11 into 80 is still 7. 7 times 11 is still 77. And there's the 3 again. So this time I don't have a single number repeating. I have a sequence of numbers repeating. And in this case, I'm always going to get a remainder of 8, and then a remainder of 3, and a remainder of 8, a remainder of 3. In the quotient, I'm always going to get a 2, and then a 7, and then another 2, and another 7, and so on. So the smallest thing being repeated is the 2, 7. So over here, I want to write my answer as 0.27, and I do want to make sure I have a bar over both the 2 and the 7. All right, let's look at a mixed number. So what if I had 9 and 5 12ths? Well, from earlier examples, we know we can just bring the whole number 9 over, write a decimal, and then we'll divide out 5 12ths to see what we get after the decimal. So let's say I have 5 divided by 12. Well, 12 won't go into 5, but it certainly will go into 50. It'll go in 4 times. 4 times 12 is 48. Get a 2. 12 into 20 just goes in once. 12 times 1 is 12. I subtract and I get an 8. Well, 12 into 80. 12 times 6 I know to be 72. So 12 times 6, we know 72. We subtract, and there's another 8. Let's divide out one more time. Well, 12 still goes into 80 6 times. 6 times 12 is still 72, and there's that 8 again. So I can see that the 4 and the 1 don't repeat, but now I'm going to get this repetition where I consistently get a remainder of 8, and I'm always going to get in the quotient a 6. So I would say my final answer here is 9.41. The smallest thing repeating is just the 6. So I'm going to get 416, and I'm going to put an overbar over just the 6. Okay, the 4 and the 1 don't repeat, just the 6 does. Let me get a sip of water. Let's do one more. So I've got 12 and 1/9. So I can go ahead and write this as 12 point something. So 1 divided by 9. 9 does not go into 1, but it would certainly go into 10. It'll go in 1 time. 10 minus 9 is 1. We bring down a 0. 9 into 10 is still 1. 1 times 9 is still 9. There's that 1 again. Okay, so I can already see I'm always going to get a remainder of 1. In my quotient, I'm always going to get a 1. So 12 and 1/9 is just 12.1 repeating. And that's it. Cool. Now, for the next 2 examples, this is a situation where we'll eventually get a terminating decimal, or we'll eventually see a sequence of numbers that repeats, but it's going to take a while. And so when that happens, sometimes your homework would ask you to round. So instead of going ahead and dividing out until you get it to terminate, or to divide it out until you can get a sequence of numbers that repeats, they'll just say, okay, let's just cut to the chase. Let's estimate this to the nearest thousandth. So for these right here, we're going to round to the nearest thousandths place. Okay, so for both of the next examples, we're rounding. Okay, let's say I have 9/14. Okay, let's go ahead and start dividing, and then I'll kind of explain what it's going to look like to round. Okay, we already know how to round, but I'm going to explain how you know when to stop with these problems. Okay, So 14 won't go into 9, but it would certainly go into 90. So 90 divided by 14, we get, well, 6. 6 times 14, I get 84. So I subtract, I get 6. Well, I need to round to the nearest thousandths place. So I definitely need to subtract, or not subtract, divide out some more. So I take 60, I divide it by 14, I get 4. All right. 4 times 14, we get 56. Add another 0. Well, let's see. 40 divided by 14. In this case, I just get 2. So 2 times 14 is 28. I subtract, let's see, I get what, 12. Now, here's the thing. I have divided out to the thousandths place, but the directions very clearly say round to the thousandths place. And we know with rounding, you always find the rounding digit by place value, and then you look 1 digit to the right. Well, we don't have 1 digit to the right in this case, so I need to do 1 more division, okay? So whatever place value you're expected to round to, you got to divide out 1 extra place, okay? So I'm going to drop down 1 more 0. And when I drop down the 0, I get 120. 120 divided by 14 is 8. All right. 8 times 14, I get 112. And I can go ahead and stop. I don't have my 0 remainder yet, but that's okay. It would eventually happen, or we would see a sequence of numbers that repeated, but we're not worried about it. The directions tell us to round, okay? So this digit right here to the right of our rounding digit would tell us that we would round up. So we would say 9/14 is approximately 0.643. Okay, the 8 tells us to round up. We add 1 to the 2, we drop the 8 off. All right. Let's try one more where we round, okay? Let's say I have 27 sevenths, okay? Now, this is an improper fraction. It's no big deal. It'll automatically work itself out, so you don't have to convert it to a mixed number first or anything like that. Just start your division. So I get 27 divided by 7. Well, 7 goes into 27 3 times. 3 times 7 is 21. I get a 6. Go ahead and add a decimal and bring it down. Well, let's see, 6 times 9 is 63, so I can't say 7 goes in 9 times. So we would say 7 goes into 68 times. 8 times 7 is 56, so I get a 4. Well, let's see, 7 times 6 is 42, so that's too much. So we would say 7 goes into 45 times. Well, 5 times 7 is 35. 5. Add another 0. So let's see, 7 times 7 is 49, so we put a 7 here. And notice this is the thousandths place, but I don't know if I round up or down yet. So I've got to do 1 more division. So add 1 more 0. 7 goes into 10 one time. 1 times 7 is 7. I get 3 left over. Doesn't even matter. I can now round. So this digit 1 here tells me that I would round down. That means the 7, I leave it alone and I chop everything after that off. So this is approximately equal to 3.857. All right. So be on the lookout for questions where it tells you to round. So whatever place value it tells you to round to, you've got to divide out 1 extra digit. So you know whether you round up or you round down. Okay. Now, in the previous video, we talked about comparing and ordering decimals. Now we also know how to convert fractions to decimals. So we're going to look at comparing fractions to decimals. We're going to look at ordering fractions and decimals. So let's say I have 2/3. Let me erase that one. Let's do 3/5, and I want to compare it to 0.65. Okay, so I want you to compare. I should put the instructions down, shouldn't I? Okay, so if you're comparing decimals and fractions, it is generally much easier to convert fractions to decimals and then compare. Okay, so we're going to convert 3/5. Okay, well, 5 won't go into 3, but it will go into 30. 5 goes into 30 6 times. 6 times 5 is 30. So we could say that 3/5 is equivalent to 0.6. Now, when we're comparing decimals, remember, we just need the same number of decimal places. So I can go ahead and add a 0 after this, and then I'm just comparing 60 and 65. Well, which is bigger? Well, 65 is bigger than 60, so that tells me 3/5 is less than 0.65. Let's do another one. So what if I had 0.75 and 4/5? Well, 4/5, let's go ahead and convert. 4 divided by 5. Well, 5 won't go into 4, but it will go into 40. It'll go in 8 times. 8 times 5 is 40. Get my 0 remainder. So 4/5 is equal to 0.8. But since 0.75 has 2 decimal places, 2 decimal places, I'm going to add a decimal place after the 8. So I'm comparing 80 and 75. Well, which is bigger? 80 is bigger than 75, so that tells me 4/5 is bigger than 0.75. All right. What about 7/3? Let me come up with a good example here. And okay, so 7/3 and 2.31. Oops, I forgot to switch back to black. No big deal. All right, so I want to take 7 and divide it by 3. Well, 3 will go into 7 twice. I get 1 left over. I go ahead and add a decimal and a 0. 3 goes into 10 3 times. 3 times 3 is 9. I get 1 left over. Add another 0. 3 into 3. Well, I get, or 3 into 9 goes 3 times. Shoot, 3 into 10 goes in 3 times. Bless my heart. 3 times 3 is 9. I get 1 left over. So I can see I've got 2.3 repeating, but let's just keep it at 2.33. So the 2's here and here match. So let's just compare 33 to 31. Well, which is bigger? Is 33 bigger than 31? Yes. So that tells me 7/3 is actually bigger than 2.31. All right. All right, now let's put some stuff in order. Let's say we have 2/3, 3/4, 4/8. Not 4/8. Let's do 4/5. Let's say we have 0.6 and 0.85. Do I like that? Yeah. Okay, so what we would want to do here is we would want to convert everything either to a fraction and then find an LCD, equivalent fractions, and compare numerators and then put them in order like that. Or we could take everything, convert it to a decimal. So I think I want to convert everything to a decimal first. So I'm going to do some side work down here. So I've got 2. I want to divide it by 3. Well, 3 goes into 20 6 times. I get 18. I get a remainder of 2. 3 goes into 20 6 times. I get another 2. So let's say that this is for now 0.66. 3/4. Well, 4 doesn't go into 3, but it goes into 30 7 times. Subtract 28, I get a 2. 4 goes into 25 times. There's my 0 remainder. 4/5. 4 doesn't go into 4, but it goes into 40 8 times. Whoops. There's my 0 remainder, so that's 0.8. Now I've got 0.66, 0.75, 0.80, 0.60, 0.85. Now we're just looking at these 2-digit numbers as if they were whole numbers. So of those, which is the smallest? Well, 0.6 is the smallest. So that's going to be my first number in line. Out of the numbers left, 0.66 is the next smallest, then 3/4 or 0.75, then 4/5 or 0.8. I'm like destroying it today. Good grief. And then finally, our largest number is 0.85. So if I were going to put all of these original numbers in order, I would put them in order like this: 0.6, then 2/3, then 3/4, then 4/5, then 0.85. All right. So when you're comparing fractions and decimals, or if you're ordering fractions and decimals, either convert everything to fractions, find an LCD, and then equivalent fractions, compare your numerators, or I think this is a lot easier, convert everything to decimals and then do your comparison. Okay, so quick recap. To convert fractions to decimals, you divide the numerator by the denominator. If you get a zero remainder, like we do on the first two entire slides, that would indicate that your decimal terminates. Otherwise, you're going to get repetition. So you could get a single number that repeats, you could get a couple of numbers that don't repeat, and then you do get one that repeats, or you could get a sequence of numbers that repeat like what we have right here. We had a 2 and a 7 that repeated. All right. We looked at examples where you had to round. And then finally, we looked at examples where we were comparing and examples where we were ordering. Okay, so again, with comparing and ordering, convert everything to a decimal, then do your comparison. Okay. So that wraps up it's happening again. I don't know what is going on. It doesn't matter. Anyway, so we've wrapped up the third video in the sequence on decimals. Next up is going to be addition and subtraction of decimals. And after dealing with addition and subtraction of fractions, you're going to like this. Adding and subtracting decimals is a piece of cake, okay? And then multiplying decimals is okay. It goes back to kind of like the idea of multiplying whole numbers. They're just kind of like an extra thing we have to do at the end. Dividing is probably what you're going to like the least out of all of this. But once we're done with adding, subtracting, multiplying, and dividing, we'll look at estimation, and then we will also look at the order of operations. So lots of things to come. Best of luck.